Okay, in this video, I just want to talk about this concept of eccentricity. It's a cool sounding name or word, uh, and all it really means is really what is the ovalness of the ellipse? All right, what is the ovalness of the ellipse? Um, is it like a circle or is it kind of really elongated and flat? Um, and and I'll show you what it looks like, graphically and all that. So we're adding another kind of letter to our collection of letters that are important for an ellipse. H and K, that finds the center. Um, A, B, and C are important. A is length from the center to each, regular vertex, and B is the distance from the center to each covertex on the minor axis, and C is the distance from the center to each foci. All right. So this eccentricity concept, we'll call it E. E is a fraction, and it looks at C divided by A, or in other words, sort of the length from the distance from the center to a foci compared to the center to the vertices, okay? The major vertices, the main ones, all right? So C can be anywhere from between 0 and 1, okay? If it were 0, then that means that the um, foci are really right on the center. If C is 1, it means that the foci are right on top of the vertices. All right? So to illustrate this, let's go back to a problem we just looked at in the prior video. All right? So I'm going to go back to that one. And it was this vertical uh, looking ellipse that we had. Here was the center. The center was 4, -2. I had a focus here and another focus here. This was a vertex here, a vertex here. The two co-vertices are over here. And you can see this one's an oval. Nobody would mistaken this for a circle or anything like that. Because what we had underneath both of these numbers here, this b was 3, so b squared, so I had a 9 underneath this one, and I had 5 squared, or 25, underneath this one. Now, what if I change some things a little bit? Because here I also have, if we see that C is 4 and A was 5, then E was 4 divided by 5, or 0.8. So that 0.8 made it look very oval-like. But what if I adjust a few things? Like, what if I make B, I don't know, smaller? If I make B smaller, I'll make C bigger. So what if I make it smaller? So if B is now 2, then C became 4 point almost 6. So 4.6 divided by 5 is closer to a number like 1. And you can see it it moved the foci. Let me watch the foci. Watch where the foci goes compared to the center as I adjust it back to where it was. See how it goes back down toward the center? So as B becomes now smaller, the focus moves away from the center, closer to the vertices, and it becomes more oval-like. Let me take it even further. Let me let B become closer to 1. You can see the focus is now really moving close to each vertex, and you can see how narrow this one becomes. Now let me take it in the other direction. What if B becomes bigger? Let's take it up to, there was a 3. Let's make it close to 4 now. So when I do it 4, C is 3 now. 3 divided by 5 is 0.6. And notice this is becoming more circle-like. And what I'm doing by doing that, let me go back to the B of 3. Watch the focus compared to the center. See how it moves? Now if I let B get closer and closer to 5, there's 4.8 for instance. This almost looks like a circle. So notice how the two foci are getting really close to the center. They move considerably away from the vertices. C is now 1.4 divided by 5, and that's what E would be. The eccentricity number is getting smaller. So if I make it even smaller yet, if B becomes the same as A, then C becomes 0. The eccentricity would be 0. And what happened to your foci? They disappeared. Let me just bring them back just for a second. There they are. They disappeared. Let me make it 4 point. I'm going to make it 4.99. There you go. You can see that's really almost a circle. Look at the two foci, almost at the center. Now let me take it back to the 5. There you go. You get the perfect circle now. So a circle is really just an ellipse for which the foci disappear into the center. Okay? So hopefully that helps a little bit with this concept of eccentricity. How oval-like, how circle-like is the ellipse. All right?